Today, this is a comeback video from E8 Group channel, YouTube channel. It's been quite a while. We have been very quiet. We're going to kick off, reboot this video, the channel by coming up with a very interesting topic when it comes to ventilation design. One of the most important component of an industrial ventilation system is what we call a stack or a chimney. And why a stack or a chimney is very interesting. Why? It is because most of the time it actually gains a bigger limelight compared to the ventilation system itself. It gains a bigger limelight because of compliance reasons. A chimney, which is very visible, which is tall and visible, becomes a subject of compliance under Department of Environment. The chimney is strongly associated to dissipating airborne hazard. So when it's associated in emitting airborne hazard, it becomes a very important component. But in actual fact, what exactly is a chimney? A chimney is refers to one of the ventilation system component. In fact, it is a means to discharge whatever exhaust which is being pulled, either via using the approach of general ventilation to generate air change, or a local exhaust ventilation system, axial exhaust ventilation system. So now, when number one, when do we use chimney? Let's quickly cover in terms of when you need chimney. A chimney is required when we are managing airborne hazards. A chimney is required when we are managing airborne hazard. If we are just merely we are just merely discharging heat, then we do not need a chimney. Why? A chimney would need a dispersion to take place so that that stationary source, which comes from an industrial ventilation system, does not affect the ground level concentration, which is very important to justify whether it's creating environmental impact or not. So that's why a chimney and stack is very important. Now, a chimney and stack requires a very, I wouldn't say rigorous, but it requires a methodological approach in designing. Unfortunately, there has been this very basic rule of thumb that chimney has to be 3 meters above, and certain distance must be required and all that. This rule of thumb is good, but using this rule of thumb without actually understanding at all the function of a chimney defeats the whole purpose. Now, first of all, we must always understand what is the purpose, what is the fundamental function of a chimney. A chimney works. A chimney works to provide. A chimney works to provide. A chimney works to provide buoyancy. It provides. It provides um, vertical discharge. It provides vertical discharge towards. It provides vertical discharge towards the environment. What exactly it does is it it creates a vertical push. It creates a vertical push in order to generate what we call effective stack height. What we call effective stack height. If you look at this is a chimney, right? This is a chimney. A chimney must have good amount of efflux velocity. It must push vertically. It must have momentum. It must also have buoyancy. Buoyancy comes from the efflux velocity, so that it will create a plume rise. It will create a plume rise. When it meets the wind, it will create a plume rise. This rise is what we call effective stack height. What does this effective height? This height will ensure that the plume opening will create a dispersion where this slope doesn't immediately come down and increase the ground level concentration, but it will keep moving vertically for a certain distance so that dilutions take place. So that is the fundamental importance of having a chimney. That is why when you do a stack emission report, you submit to Department of Environment. That is why you need a minimum velocity, because when you don't have that minimum velocity, you cannot create the stack effect, the effective stack height. You can't create effective stack height. What will happen is you will have downwash. You're going to have downwash. What is going to happen is the chimney is going to basically splur a discharge. It's going to basically, assuming that we have sulfuric acid with a concentration of what you call 500 ppm here, that 500 ppm is not going to go through dilution, probably a very small amount of dilution. And by the time it drops probably 20 meters from the periphery of the stationary source, it's still going to be about 400 ppm. Let's say we have a dispersion which goes vertically, that 500 may drop to about 100 or even lower. But again, okay, this is just for explanation, yeah, but you're not going to discharge 500 because the plume has its own limitation. Now, you can use chimney. We need a chimney to use dispersion, but if the loading is too high, we will need to use the air cleaning device to reduce the loading first. We're still going to depend on plume rise, but if the loading is very, very high, we're going to use a scrubber, we're going to use air cleaning device, we're going to use activated carbon or permanganate, or depending on what could remove that particular airborne hazard, then only we're going to go to chimney. But regardless of that, okay, the focus today is chimney, not scrubber. So chimney has to produce plume rise. It must be able to do a dispersion, a vertical dispersion at the elevated level without immediately having downwash or channeling the discharge to the ground level concentration. That's the purpose of chimney. But how do we understand? How do we achieve this? First of all, we must always understand the impact of wind towards the building. When the wind moves from one angle towards the vertical wall, the first point of impact. Number one, at this point, what's going to happen here is the wind is going to go through a cyclonic motion. This is why a ventilation system, generally, name it an industrial ventilation system, which could be general ventilation, it could be a machinery ventilation, which could be a fuel burning flue, or it could be a local exhaust ventilation system. You cannot dissipate at this outlet. You have to have a chimney. Why? If you dissipate it or you discharge it here, it's going to mix with this entrain, this cyclonic effect, and it's going to come back into the building. If you have an AHU inlet around here, that's going to be even worse. It's going to entrain back. That is why we must understand all the circulation zone. Number one, the first circulation zone we must understand, when the wind hits the first edge, the leading edge of the roof, it's going to create RZ1. RZ1 is the first cyclonic effect. Then this cyclonic effect is going to keep moving. It's air. It has momentum, right? It has energy. It's going to keep moving towards the end of the building. When it moves towards the end of the building, of course, it's going to weaken, but it also is going to be in a very erratic, turbulent region. So you see, starting from here until the end, you're going to have this turbulence, but of course, it's going to dwindle. So that is why we cannot place the chimney here. We're going to place the chimney towards away from the edge, if it is possible. And we're gonna, if you have no choice, can, but we try to keep it as high as possible. But we also need to understand this. We also need to understand where is the cyclonic effect. A good designer can use methods like Wilson modeling or any other models available to calculate, to justify, to know, to determine all this recirculation zones. So you got recirculation one, recirculation two, and you have a roof wake boundary. Now that the air comes in here, okay, it basically what happens is you have a wake boundary around this region, which also can be calculated. We have to ensure that the plume, okay, always goes above outside this wake. You see, and we always have to ensure the plume basically leaves. So what I'm trying to say is chimney has to be placed on top of RZ1, RZ2. We also have to take note of RZ3. You do not need to be above RZ3, but we have to assume that the stack effective height can break up and come out of the recirculation zone. Okay, that's the most important thing. RZ1, RZ2 is the most important part to take note. Never discharge a chimney which has airborne hazard, a pollutant, another way of saying it, at the wall. You definitely need a chimney. But what else do you need? Do you need a chimney more than 3 meters. I mean, it's about time we don't use the 1956 memorandum, Clean Air Memorandum Act and just blindly use 3 meters. We can always calculate. It's no harm. I mean, if you could actually extend it slightly higher, if you can have a proper support and all that, what's not? If you can have efflux velocity a bit higher, then why not? I mean, higher efflux velocity is not the substitute for better plume rise, but it is definitely will have a lot of better impact to fight erratic other turbulent, or if let's say if you have your factory is situated, your chimney is situated in a region where the wind velocity fluctuates. Sometimes it can be low, it can be high. It's good to have a higher velocity so that the wind does not affect tremendously on the actual performance of the chimney. All right. So these are quick tips on how to design a chimney, a quick tips how to ensure that the system provider you're engaging fulfill this requirement, a quick tips on understanding clean air regulation, which requires all the components of ventilation, especially chimney, to have a standard criterion. This is also a tip to what you call to make ventilation system which are involving in airborne hazard control, Department of Occupational Safety and Health, DOSH related matters. Now, when it comes to local exhaust ventilation system, there is a lot of misconception that I just need to worry about hood, capture velocity, transport velocity, or chimney doesn't come under my purview because it's under Department of Environment. No, it doesn't work that way. Department of Environment and Department of Occupational Safety and Health, they are facilitating end users to manage their ventilation system well. But a ventilation system has its suction point, aspiration point, which is hood, exhaust point, suction point, and it has a discharge point, which is a chimney. So it all comes under one control. So a person who has the system must be able to control every component. That means you have to ensure that you have efficient adequate amount of capture velocity, adequate amount of transport velocity, good filtration velocity, no erratic drop in static pressure, differential pressures between components, between elbows, between filters, well taken care of, and efflux velocity, which can become a very good performance index in managing this. Why? A flow rate at chimney comes right after a fan. It can always be taken as a performance index because it churns out the actual volume of air right after going through every single work, right after going through every single restriction. So a chimney emission, a good design of chimney is important. Uh, the performance monitoring by taking the flow rate is important. It also can be used as to manage, to gauge overall performance of the system. That's all from us, E8 Group on Chimney. Do email or contact us if you'd like to know more about this subject or any other subject on industrial ventilation system. Good day. Bye-bye.